If V naught is the stopping potential, then kinetic energy maximum is equal to H nu minus nu naught. So this maximum kinetic energy, that is the V naught is the applied potential, multiply the electron charge, E V naught is equal to H nu minus H nu naught. Thus V naught is equal to H nu by E minus H nu naught by E. This is the form Y is equal to mx plus c. The graph with V naught on y-axis and nu on x-axis will be a straight line with slope h by e. So knowing the values of different frequencies and applied voltages, we can find out the Planck's constant experimentally in our lab. So we have to do this experiment in our lab. Photons. Einstein postulated the existence of a particle called a photon. To explain detailed result of photoelectric experiment, energy of a photon is equal to h nu is equal to hc by lambda. Photon has zero rest mass. Always remember, zero rest mass. Travels at speed of light. It explains instantaneous emission of electrons in photoelectric effect, frequency dependence. Some important definitions. First, radiation. According to Maxwell, when a charge is accelerated, it creates some electric and magnetic fields which are correlated to each other. They can move in form a wave on space with finite velocity. These are known as electromagnetic radiation of the velocity of the radiation, and it is given by V is equal to 1 by root over mu epsilon. In free space, V is equal to velocity of light, c is equal to 1 by mu naught epsilon naught to the power half is equal to 3 into 10 to the power 8. Theoretically, the wavelength lambda of these radiations may have values from lambda tending to 0 to lambda tending to infinity. Some examples of EM waves are visible light in the range of 4000 angstrom to 7800 angstrom. X-rays, its wavelength range is 0.1 angstrom to 10 angstrom, etc. Reaction of matter on radiation. Let us see what happens when some radiation is incident on a surface. There are three possibilities. Some part of radiation may be reflected, some part of radiation may be transmitted, and some part of radiation may be absorbed. From conservation of energy, we can write Q is equal to, Q is the total energy of incident radiation is equal to energy absorbed plus energy reflected plus energy transmitted. So we can write 1 is equal to A plus R plus T. What is A? A is, if you divide this equation by Q, then this is 1 by QA by Q plus QR by Q plus QT by Q. So QA by Q is A, is known as absorptive power. R is QR by Q is known as reflective power or reflection power. T, transmittive power or transmission power. T is equal to QT by Q. Black body. What is black body? A black body which absorbs all the incident radiations. Clearly, for a black body, absorptive power is equal to 1 and reflective and transmittive power is equal to 0. The best black bodies in nature are lamp black, whose absorptive power is 0.096. 0.96, and platinum black, its absorptive power is 0.98. But for experimental purposes, one can prepare a cavity having absorptive power almost equal to 1 with inner walls polished with platinum black. Radiations by hot bodies. When a hot body is heated up, it changes its colors. This is because it emits radiations. At first, we see the color of a hot body is red. Then it becomes some orange, and at last, after reaching certain temperature, it becomes white. This all signifies that hot body emits radiation of high wavelength and low temperature. At high temperature, it also emits the radiation of lower wavelength. Black body radiation. When a black body is heated up and kept at a fixed temperature, then electromagnetic radiations are emitted from inner walls of the cavity. This is black body. This radiation is partially reflected and absorbed by the inner walls of the black body itself. After some time, the cavity is filled up by electromagnetic radiation. The temperature of the black body is kept fixed. This implies that the radiation is in thermal equilibrium. This means that electromagnetic radiation emitted per second by the walls of the cavity is the same as absorbed. In thermal equilibrium, the energy density of the electromagnetic radiation remains constant. As we have a hole in the cavity, the radiation comes out from this hole, which is a part of inside radiation. Now, energy density. What is the energy density? At a particular temperature T, energy in the cavity per unit volume is called energy density. That means energy per unit volume. It is denoted by U. Spectral energy density. These are certain definitions. It will be required later on. At a certain temperature, the average energy density between the wavelength range lambda and lambda plus d lambda. D lambda is very small. Lambda and lambda plus d lambda is given by U suffix lambda d lambda. That means U is dependent upon lambda. Where U, lambda is called spectral energy density. The relation between U and U lambda is capital U is equal to integration 0 to infinity U lambda. Here U is a small d lambda. One can use the frequency spread. Then instead of U lambda, we will use U nu. U suffix nu. This is defined frequency range nu and nu plus d nu. Emissive power. Total radiation energy emitted by unit surface area of the black body at a certain temperature is called emissive power of the black body. It is denoted by E. It will be used frequently for different derivation purpose. Here we will discuss later on.